We're going to solve the system of linear equations pictured here. Notice that we have three equations. You can see them as three separate lines, and we have four unknowns, x, y, z, and w. So we're going to begin by forming the augmented matrix. Remember that this is a shorthand for our equations, where we write down just the coefficients. So we have these four unknowns. So we'll have a column for each of them. We have an x column, a y column, z, and w. And we draw a bar to show the equality sign. Okay, so if we were to read this off, we're going to write down the coefficients. So our first equation becomes our first row. We have 1 x's. We don't see any y's. We have -1 z's. And we don't have any w's. And at the bar, we're going to write what we're equal to. We're equal to 1. Our second equation, y plus 2w equals 2, will look like, well, we have 0 x's, we see 1 y, no z's, and 2 w's. And this is equal to 2. And our third equation, 3x plus y plus w equals 0, has 3 x's, 1 y, no z's, and a w. And this is equal to 0. So this is our augmented matrix. Sometimes we may not include this bar. So if you're told that, that we have an augmented matrix and we don't see any bars, it is understood that the last column is our augment. Okay, now that we have our augmented matrix, we can do row operations to reduce it to echelon form. Okay, so what we're going to do to begin with is we're going to look at the leading terms of each of these rows. So here we have leading terms. That's the first non-zero. That's the first non-zero entry in each row. So looking from left to right, we look for that first non-zero entry. Notice that in row 1, that this leading term is as far left as possible. Okay, so we're going to be doing this process using just row 1 as is. Okay. Okay, so our goal in getting to the echelon form is going to be to see that our leading entries are going to be moving down and to the right. So as we look down the rows, our entries should always be further to the right of each other. And so what we're going to do to achieve this is we look at this first entry in row 1, and we want to get rid of all of the non-zero terms that live below it. So here we see a 3 living below this one. So what we're going to do is we'll take row 3 and we're going to replace it with row 3 minus 3 times row 1. Let's break this out separately just so we can see this really clearly. Okay. So what we want to do is take row 3 minus 3 times row 1. Okay, so I'm going to write out my row 3, which was 3, 1, 0, 1, augmented with 0. And then I'm going to subtract 3 times row 1. Okay, so that'll be 3, 0, negative 3, 0, 3. I've just multiplied everything in row 1 by 3. You can do that as a separate step if that makes you feel more comfortable. Okay, so let's do some subtraction. We have 3 minus 3 is 0. 1 minus 0 is 1. 0 minus negative 3 is going to be 3. And 1 minus 0 is 1. Our augment gives us 0 minus 3, or negative 3. So this result is our new row 3. And when we look at this again, so I've just recopied it so that the first row 3 was replaced with this result, the row 0, 1, 3, 1, negative 3. Okay, and now when we look below our leading term in the first row, we see all zeros. Okay, great. We are good to move on. Now we're going to look at row 2. If we look at this leading term, the first non-zero term, we have a 1 here. And looking below us, we see a non-zero term below us. Okay. So what we're going to do is subtract away row 2 from row 3. So we're going to replace row 3 with row 3 minus row 2. Again, let me break this out just so we can see it really explicitly. I think it can help to write out what we're doing exactly. So we have 0, 1, 3, 1, negative 3, and we're subtracting away row 3. So that's 0, 1, 0, 2, 2. Okay. Doing the subtraction, we see a couple of zeros, and then 3, negative 1, and negative 3 minus 2, or negative 5. Okay, and now when we're looking at these, if we look at our leading terms, so that's the first non-zero entry in each row, notice that they, as we look down, they are moving to the right. So as we look at lower rows, our leading entries move to the right. We've got zeros below these terms. Okay, so we are now in what's called the echelon form. Our leading entries move down and to the right. What we're going to do next is go from the echelon form to the reduced row echelon form. In the reduced row echelon form, we want all of our leading entries to be equal to 1. And we want that each leading entry is the only non-zero term in its column. So what that means is that our variable is only going to appear in just a single equation. Right now, for example, our variables were x, y, z, and w. We see that this variable z occurs in both equation 1 and equation 3. So our goal is going to be to limit it to just a single equation. Okay, so let's try that out. So in the upward phase of row reduction, what we're going to do is we're going to start off at the bottom, at our last row, and we're going to clear out, and by that I mean make 0 any non-zero entries that live above it. Okay, so here we're starting at this last row. We're looking at this pivot, at that leading entry, and we want to get rid of any non-zero entries that live above it. In order to make the algebra a little bit nicer to work with, let's rewrite it so our coefficient is equal to 1 instead of 3. Okay, so what we're going to do is just replace row 3 with 1/3 row 3. All right, this introduces some fractions, but that's not the end of the world. Sometimes we'll have some fractions to work with. So this gives us, each term gets divided by 3. So we have 0, 0, 1, negative 1/3, negative 5/3. Okay. All right, we are looking at row 3. We look above it, we see this -1. Okay, so in order to make that term equal to a 0, well, what we could do is just add row 1 and row 3. So I'm going to replace row 1 with the sum, row 1 plus row 3. You might also think of this as row 1 minus negative row 3. Okay. Okay, and let's break this out just so we see it nice and clearly. We're going to have row 1 plus row 3. So 1, 0, negative 1, 0, 1, plus row 3, 0, 0, 1, negative a third, negative 5/3. And we're just going to add these guys together. So their sum will be 1, 0, 0, negative a third. And then 1 minus 5/3 is going to be negative 2/3. So this will go in row 1. Okay, so we have our new row 1 in here. If we look at our leading terms, notice that they're all equal to 1. And they move down and to the right because they're in echelon form. And above each of them, we have all zeros. Okay, so we are now in the reduced row echelon form. Okay, so these variables x, y, and z, notice that x only appears in one equation, y only appears in one equation, and z only appears in one equation. So we've really separated this about as much as we possibly can. Okay. Notice that the payoff, what we have to pay for that, is that w occurs in multiple equations. Okay. So this sometimes happens, but what we're going to see is that we have infinitely many solutions, and that W term is going to show us sort of how we have these infinitely many solutions. Okay. So now that we have our system into the reduced row echelon form, we can rewrite it as a system. Okay. So the way we read this off, again, remember that that these numbers to the left of the augment represent coefficients of our unknowns. So this tells us we've got 1x, 0 y's, 0 z's, and negative 1/3 w's. And that's going to be equal to negative 2/3. We have 1y. We have 0 x's, 1y, 0 z's, and then 2 w's are equal to 2. And we have 0 x's, 0 y's, 1 z minus 1/3 w equals negative 5/3. And it's very convenient for us to solve for those leading term variables. So we can write this as x equals 1/3 w minus 2/3, y equals negative 2w plus 2, and z equals 1/3 w minus 5/3. All right, so x, y, z, x, y, and z all depend on w, and w doesn't have any other restrictions. So we call it free. So it can be any value. Okay. So if we know what w is, then we can say what x, y, and z are going to be. Okay. So one final way of writing this is to write our solution in vector form. This just writes it as a four tuple. So it just organizes it. So we have x, y, z, and w are going to be equal to 1/3 w minus 2/3, negative 2w plus 2, 1/3 w minus 5/3. And then the way that we write w is just as itself, as w. Okay. And so this is what we mean when we say write our solution in vector form. Great.